Move it to record.
Okay, you're good.
We're starting with chapter 3. And this is just a brief introduction. It's a lot of definitions. We may have done this before, but the first thing chapter 3 defines is an element. And an element is a substance that cannot be broken down into a similar substance by chemical means. Now, what that means is that it can be broken down, say, in a nuclear reaction, but you are not going to be able to do it in the laboratory, not by chemical methods, okay? Little bit of difference. It can be broken down, but it takes more power than we have in the chemistry lab. Okay, the next thing the book defines is an atom. And an atom is the smallest particle of an element. Okay, and we build from there. So next we talk about molecules. A molecule is two or more atoms bonded together. Okay, two or more atoms bonded together. They can be the same kind of atom, or they can be two different atoms. This is a very general term. Just two or more. 2, 3, 4, 27. Still a molecule. And then from there we have compound. A compound is two or more elements bonded together. Okay, so a compound is a little bit more specific than a molecule. All compounds are molecules. Not all molecules are compounds. Okay, since this implies you have to have two different elements. So for instance, a molecule would be something like P4 or O2. A compound is something like water, H2O. Or methane, CH4. Here you have the same thing, here you have two different things. You could have three or more things bonded together as well, but we'll get to that later. States of the elements are either solid, liquid, or gas, abbreviated S, L, or G. I think we've been through that before, but S is solid, L is liquid, G is gas. And these are generally color-coded on your periodic table. Not always, but usually. And I'm just writing P table for periodic table. Solids tend to be colored black. The two liquid elements are colored blue, if we follow this color coding. And the gases are colored red. Now, it doesn't happen on every periodic table, but it does happen on quite a few of them. Naming elements. Some names you're quite familiar with, like carbon, oxygen, nitrogen. Others you're familiar with, but the names and the symbols don't have a lot to go together. For instance, I'm trying to think. I had down gold, but gold doesn't really work. But an old name is gold. Mostly its symbol is old. The symbol for gold is AU, and AU comes from the Latin word, not Latin, Latin word, meaning shining dawn, AURUM, and that means shining dawn. Okay, let's try that again. That's shining dawn. So the original name for gold was very old. It was aurum. That's where we get its symbol. Our translation is gold, and this name has a very old origin. Other names are quite a bit newer. They're named after scientists, for instance. So if we look at the element whose symbol is Cm, that is curium, which is named after Marie Curie. So the newer elements, the ones that have been found more recently, tend to be named after people or places. The first element Marie Curie named, she named after her homeland, which was Poland, and it's polonium. Older things are named, they either have Latin or German or Greek root words, and they're named after some natural phenomena, generally. If you're looking for the symbols of the elements, is this still in focus? Should I move this up? Okay, symbols are either one capital letter, one uppercase, okay, so you can have one uppercase letter or one uppercase plus one lowercase. C-A-S-E, sorry. That says one lowercase, although you can't read it because I'm writing way too far away from myself. So for instance, an uppercase letter, carbon, is a single C. Oxygen is a single O. Cobalt is a capital C and a lowercase o. Cobalt is not carbon monoxide. Carbon monoxide is a capital C and a capital O. So these two symbols are not the same. Okay, it's always an uppercase, then a lowercase, or simply an uppercase. If you see two uppercase letters, they are together and they make a compound. Lastly, 7 of the molecules, or 7 of the elements on the periodic table, are always represented as what we call diatomic elements. This bothers students a lot. It's only when you see these elements in a chemical equation or in a sentence and they are by themselves as elements that they are written as diatomics. That means 2 atoms together, di meaning 2. When they are bonded to something else, you can have just one of them. So they are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So that's H2, N2, O2, F2, Cl2, Br2, and I2. And the easiest way to remember that is they tend to make, with the exception of hydrogen, which is way over here, they make a 7 on the periodic table. A rather square 7, but a 7 nonetheless. And I learned this from my son when he was in the 5th grade. His science teacher told him this. If you go to the far right-hand side of the periodic table, you have nitrogen. Right next to it is oxygen. Then fluorine, chlorine, bromine, and iodine. So when you take them out of the periodic table, 6 of them make a very square 7. I shouldn't have put 2's after these. They should just, in your periodic table, they'll just be N, O, F, and Cl. But you need to remember that when they are alone, they are diatomic. If you have them bonded to something else, like table salt, NaCl, there's a single chlorine. But when chlorine is bonded to itself or as an element, you have to show it as Cl2.